Within the civilian marketplace, there are not many of its size that have the technology on board, which is rather sophisticated in terms of the autopilot system, and have the payload carrying characteristics of the Prion. Both optical payloads, so there's video cameras, there's high resolution photogrammetry stills cameras, there's all of the stabilization gimbal systems that go hand in hand with those camera systems, which are quite sophisticated and sizable. Then there are, again, more advanced cameras such as hyperspectral cameras. We have integrated a LiDAR onto the platform as well. We're in the process of doing meteorological instruments for measuring all sorts of parameters about the atmosphere that you fly through. And they dual purpose for pollution monitoring. There's a whole raft of different ideas of how you can use the vehicle, and they're very varied. We know that we have a demand from industry for pollution monitoring. We have a demand from a wide variety of clients for observational technology in the air. And we also work with a lot of research groups, such as the British Antarctic Survey. And we have been approached by a lot of industry. So pollution monitoring for oil pipelines that suffer vandalism that are onshore in certain territories. An awful lot of observational demands, both from agencies that relate to governments, but also private individuals that want to maintain a degree of security about areas that they work or areas that they're responsible for. Law enforcement agencies are interested for marine pirating. Remember, the platform has got an endurance characteristic that's over 1,000 kilometers, so we can cover large tracts of areas over the sea. And we have the sophisticated systems on board that will enable us to report back whether a vessel is expected to be in an area, licensed to be in an area. So certainly marine agencies, marine policing, observational work against poaching in Africa, for example, and for also search and rescue requirements here in Europe and in the UK. So we had an approach from an entity working for the Scottish Police that wanted to do search and rescue in the Highlands with a fixed-wing UAV that has long flight endurance characteristics. We've had approaches for us to monitor the changes in temperature of the electricity cables between pylons. Where a cable starts to fail, it has a heat characteristic which is different from a cable that's properly intact. In a similar sort of heat sensing fashion, we know that there is an application in fire prevention within forested areas. So before you get a forest fire, you get a build-up of heat in the forest that's localized to a spot that's obviously going to combust. And so there are thermal devices, thermal cameras that you can fly, which will observe the change in the transient temperature across a forested area and preempt a forest fire, which we know is a big concern in lots of regions. So the service level that we provide at the moment really has 4 elements to it. We design and manufacture unmanned air vehicles, although we have our principal design already in place, and we try to adhere as much as possible to that because it's a proven successful platform that's been flying since 2008. We do deviate away from that, and a good example is how we did so for the British Antarctic Survey to accommodate one of their rather large camera systems that they want to use in the Antarctic. But in addition to building the aircraft, then we clearly have a revenue stream of performing services for clients. So this is a turnkey service provision, whether it's an observational surveillance type exercise or whether it is to fly meteorological surveys. Whatever the requirement may be for the client, we can provide a turnkey service of aircraft and field crew to conduct that activity. There's a lot of equipment out there. It's very, very highly calibrated, and it needs to be maintained and serviced and kept up to date. So there is some repeat business through service and maintenance. The final area where there is an absolute requirement is in our fixed wing pilot academy. And this is where we train people to fly these specific aircrafts, both with the automated onboard systems, but also in a manual fashion, which they may need to use in the event that something occurs that requires a manual pilot to intervene with a mission. So the aircraft are particularly safe when we operate them correctly for two fundamental reasons. One is they go through an awful lot of pre-production testing. All of the components are rigorously tested. We are very diligent about making sure that the items that feature on the aircraft, from one extreme, for example, the engine, to another extreme might be the hinging in an elevator, all of those individual items go through a very selective process when we decide which one we're going to purchase for the use on the aircraft. They all have manufacturing tolerances that we understand, both in terms of temperature variation, humidity variation and such like. So the material science is well understood. So you end up with a very reliable airframe through a process of rigorous testing. Then in addition to that, there is the training of the field crew. And really the safety of the aircraft is only as safe as the person's whose hands it's being operated in. The field crew are trained here at our fixed wing UAV pilot academy, and they're trained both in the theory and the practical use of the equipment, bearing in mind that the equipment is rather sophisticated and the technology on board the airframes is leading edge. And the autopilot system is truly a very competent contribution to the safety factor, the overall safety factor of flying these UAVs. The sense and avoid technology on the aircraft, it comprises a couple of video cameras with real-time video feeds back to the ground station. And it gives the ground crew two video feeds. One is comparable to a fixed pilot's eye view, so the view a pilot may have if he was sat in that aircraft. And the second one is a steerable gimbal controlled video camera positioned underneath the aircraft, so you have observational awareness of objects ahead of you and below you. So these sense and avoid technologies, which we've developed ourselves in-house, provide us with this dual video feed back to the ground station as a real-time input for the field crew. A big differentiation that we have in the marketplace against our competitors is the number of years that we've been operating these aircraft. The first aircraft flew in 2008 and we've been using them every year since then in a variety of different arenas. We've used them inside the Arctic Circle, we've used them in all sorts of temperature and different climatic conditions. We've used them in snow, in rain, in hail, and on fine days as well. So lots of different variety there is captured within our experience envelope. So the big differentiator, apart from the fact that the platform is tried and tested, is that our field crews are also long in the tooth and very competent.